Okay, so on to 6.3, which is the last of the transformations we're going to look at. And the first use of what we call vertex form for a parabola. So get out your highlighter, whatever color you want. This equation here is called vertex form, and we're going to use this a lot when we do optimization problems, which is 6.5. And you're going to use it a lot moving forward in grade 11. Okay, so factored form, like having the x-intercepts, is important, but vertex form is also very important and works even when we can do something called completing the square to get it to vertex form, which helps even when an equation is not factorable. Okay, so then you can deal with more difficult concepts. So the first two slides are a review of what we've already done. Okay, so the value of A, so the A number is the number out front here. So this A value is 1, this A value is 2.5, negative 2, negative 0.5. Okay, so then if it's a positive number, the direction of the opening is up. And if it's a negative number, then the direction of opening is down. None of these have been translated or shifted. So each vertex is 0. Sorry. And so each axis of symmetry is also 0. X equals 0. So these parabolas still all start at the origin. Okay, whether they're up or down or skinny or compressed, it doesn't matter. Okay, so the graph of ax squared, y equals ax squared, is the image of the graph of y equals x squared after a vertical stretch or compression. So one of the last examples we're going to do today is writing what kind of shift has happened to your parabola. So it's important. We're going to try to use words like vertical stretch, compression, reflection. Okay, so stretch, compression, and reflection in the x-axis. All right, so this means if you have a number greater than 1, and then less than 1, would be a compression. So stretch would be what you could call skinnier, and then a compression would be a little bit wider, and then reflection in the x-axis means opens down. So when the A value is negative. Okay, so we're going to try to use these math terms. All right, then the next shift we did was a positive or negative value that did not have an x term, okay? So when we do vertex form, we're going to call that number of the q value, okay? So the value of q, the value at the end. So here it's 0, here it's +2, +4, -1, and -3. So the positive and the negative do matter, right? All of these have a positive a value out front here. So they're all open up. But now the vertex has shifted, okay? So this basic one, the 0, 0, now is going to be moved, okay? So if you want, get out a different color and write, I'm going to write beside the value of q what's happening. So this has been moved up 2, down 4, up 4. I was looking at the next one, sorry. Down 1 and down 3. Okay, so these graphs have been, so we call this a vertical shift up or down. So now the the y value of the vertex is different. Okay, so it's up to, which means that it's going to be 0, 2. So maybe I was just thinking if you want to write this here, changes y value of vertex. Or you can write that over here if you want. They go together. Okay. So then this is 0, 4, 0, -1, and 0, -3. Sorry, that's a terrible 3. Okay, and we still, the x value is still 0, so the axis of symmetry is still 0. So shift up, shift down. So y value of vertex is shifted up or down. If you prefer those words. Okay, so then this is a positive number, and this means a negative number. Okay? All right, so now on to the last sort of translation we can do. So your textbook sort of uses the words interchangeably. You can either call it, let's pick a different color here, a horizontal translation or shift. That means the same thing, okay? So let's graph. Now we have something happening inside the brackets here, okay? So that in vertex form, we call this number inside the brackets here the p-value. Okay, so you'll see that when we do the summary slides. So we'll go back to the beginning and let's make a table of values. So if you do -2 plus 2 is 0 squared is 0, is going to be +3. -1 plus 2 is 1 squared is 1 plus 3 is 4. 0 plus 2 is 2 squared is 4 plus 3 is 7. 1 plus 2 is 3 squared is 9 plus 3 is 12. 2 plus 2 is 4 squared is 16 plus 3 is 19. Okay, so let's plot the points. -2, 3. -1, 4. 0, 7. 1, 12. 2, 19. Okay, so now we want to make our parabola symmetrical. So what is the step pattern? It's got an a value of 1. So the step pattern is 1, 3, 5. 7 maybe will fit on here. So over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, 2, 3, 4, 5, over 1, up 1, 2, 3, 4, 5, 6, 7. Okay, so now we have a vertex of -2, 3. Okay, so how is the equation related to the coordinates of the vertex? All right, so I got this vertex from the graph. I just looked, there's the vertex, -2 and 3. But you can use the equation to find the vertex. So the +3 does to the y value of the vertex. We already, that was the last translation we did. So it moves it, it's positive, so up 3. Or a vertical shift of 3. And then the +2 does to the x value of the vertex. So now our base vertex, or basic vertex is 0, 0. So if you're moving to the negative 2 for the x value of the vertex, it moves, I'm going to put left 2, oops, or it goes to negative 2. Okay, so, but that looks different than what you would expect, right? So here we have the vertical shift, so is fine. It's a positive 3, moves up 3, great. But when you do a horizontal translation or shift, and horizontal is like left and right, then it's going to be the opposite. So that positive 2 means that you move left, and if it was a negative 2, then you would move right. Okay, so we'll summarize that in the next slide, okay? Oops. I just want to revisit the y-intercept, okay? So when you have the equation in this form, which is called vertex form. It is not standard form. So we need the equation in standard form, which is ax squared plus bx plus c, and in order to find the y-intercept, okay? So that means you would have to do a little bit of expanding and simplifying. I would write this out like this, and then FOIL, x squared plus 2x plus 2x plus 4 plus 3. So then you get x squared plus 4x plus 7. And the y-intercept, of course, is the value down here. Now, looking at the graph, we could have seen, I'll keep the same red color, okay, that the y-intercept is 7. But again, that's a way you can sort of check your answer as well. Okay. So what happens when we are going to do this horizontal translation? The thing with vertex form, so where I highlighted it in this yellow up here, we're going to do a summary down here. If you want to highlight it in yellow, this is called vertex form. And if you notice in vertex form, and this makes a big deal, in here, inside here, it is negative, okay? So that means that's where you get the opposite change, okay? So here, there's part of vertex form where it's negative p, and that is going to matter. So what it means is, let's say, okay, so this base function, it's like it's like a 0 at the end. This is our basic parabola, right? So now when it says x minus 2, what that means is you're actually doing x minus 2. Sorry. So this form is because of the negative in there. Sorry, that goes down here. So then this is like x minus negative 2. That's where you're going to get x plus 2, whereas this one is just x minus positive 2, which just makes x minus 2. So that's why it looks opposite, okay? So when it's negative, the value of p is actually positive 2. When it's negative, positive 4. When it's positive, then, I'm going to use a different color here, then it's going to be negative 2. Or if it's negative 4, it's going to be positive 4. And then it has to do with the vertex form having a negative p in it. Okay, so this is the only one that's a little bit weird. All of these have a positive a value out front, so they're all open up. But now the vertex, so this is going to change the x value of the vertex when you do horizontal translations. Okay, so this is going to be 2, 0, 4, 0, negative 2, 0, negative 4, 0. So it's been shifted left or right, which is horizontal. So now the axis of symmetry, because axis of symmetry is always x equals, then you have to use the x value from the vertex. Okay? So we are now shifting in the horizontal direction, right or left. So a shift right and a shift left. So if P is greater than 0, so this is where it's going to be a shift right and that will be positive, and then it's going to be a shift left when it's negative, but inside the brackets, it's going to be opposite. So if you want, because you don't have to solve for it ever, if you just want to remember it this way, then that's fine. It's the opposite, okay? So when it's negative, you shift to the right or in the positive direction. If it's positive, you shift in the left or the negative direction. So it's opposite. Okay, so let's do some more examples. Oh, this is just the summary page. Now is going through everything. Okay, so the equation for the axis of symmetry, x equals p. That p is the x value of the vertex. The basic step pattern, and then you multiply by the a value. If you have an a value greater than 1, then it's a stretch. Less than 1, but not negative, it's compression. So stretch is skinnier, compression's fatter, and then this means if you have a negative a, then it's going to be open down. And then when you have a positive value, like the Q's out here, so this is a positive value, shifts up, a negative value shifts down. That makes sense. Oh, here it is. Positive Q, negative Q. Positive Q up, negative Q down. And then this is opposite. A negative inside the brackets, you go to the right. Positive inside the brackets, you go to the left. So this is the one that's really sort of what the opposite of what you would have probably expected. Okay? All right, so there are a bunch of different kinds of questions you could be asked. So the next few days we're going to spend using vertex form and drawing parabolas. But here, this is just given the equation, you just have to describe what's happening. So when you do this, what I would do is go in order, okay? So actually, I'm going to use different colors, all right? So start with this number here. So that is a vertical stretch because it is bigger than it's like not a fraction, it's bigger than 1. And then the number inside here, that's a horizontal shift right? So it's shifted to the right because it's a negative, so it's the opposite, 3 units. Or by a factor of 3, that's fine, you can write that. And then this one out here, the last one, is a vertical shift up 4 units. So yes, it is simple to say, you know, the a value, you multiply by 2, the step pattern, shift right 3 units, shift up 4 units. Try to get used to using the words vertical stretch, horizontal shift, again, because you're going to do this again in grade 11, okay? So you want to take that on as well. Okay, so now I actually need a 4th color, okay? So here, I'm going to start at the start. So when it's negative, we call that a reflection in the x-axis, or opens down. Then we have the a value. So now that's less than 1. It's a fraction, essentially. So we call that a compression. And then we have the horizontal shift. Again, this one's going to be left 5 because it's positive, right? So you're doing the opposite. And then you're doing a vertical shift up, or sorry, down 7. Okay. So now this question down here wants you to, let me see if I can get these colors right, match the equation to the parabola. So when you do this, when you take a look at your equations here, what I would do is you write down what you know. So for example, this is opens down. This one's up, up, down, up. So that helps narrow down your choices. Okay, and then use the other points to write the vertex. Okay, so I'll just use different colors. So this means a shift to the right of 4, and this one means up 5. So you're looking for a vertex of 4, 5. That opens down. Okay, so you go 4, 5, opens down. It's this red one here. Okay, so you can see the vertex is 4, 5. Okay, so same thing down here. So now here we have, it's positive, so we're going to change it. -1. So you're shifting left 1 and down 5. Opening up though this time. Oops, I used blue, sorry. If you're going by the same color, sorry. Okay, so go to -1, -5. There it is. And opens up. This is B, okay? This one has shift -6. But no Q value out here. So that means 0. So -6, 0. That's this one here. Just double check. Oh yes, it's opening up. Okay, that's that parabola. And then we have +8, which changes to -8, a move left and a move up. So left 8, up 1. That is D. And then by default, obviously that's the last one, but let's just go through it again. -7 makes a +7 and a +3. So these are all vertexes. Okay, so we're looking for 7, 3, opening up. That's E. Okay, so that's a different type of question you could be asked. And then this one here, write an equation for a parabola that satisfies the following conditions. Okay, so even if this was in class, I would give you what vertex form was. Okay, so you could look at that and plug in what you're given here. So it says that vertically stretched. I'm just going to show all my work, okay? So vertically stretched by a factor of 6. That means that the A value is 6. Reflected in the x-axis. That means it's going to be negative. Shifted left 7 units. So that means that the P value is -7. Okay, so then you can even think of it like plugging it in. -6. And then again, when you do x minus -7 squared, even if you forget that that's going to change into like the -7, you could automatically put +7, but you can also solve for it too. And then there's no vertical shift. Okay, so now this question says to graph each using vertex and step pattern. Okay, so that means that you need to show it. What's the vertex? So here we have, this means right 6 and down 9. 6, 9. And step pattern is 1A, 3A, 5A. So our A value is 3. Now, if you're getting good at this and you don't feel like you need to show the multiplication, you can just write what the final answer is. That's fine. So you would just write 3, 9, 15. So over 1, up 3, 1, 2, 3. Over 1, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I don't think we're going to be able to go farther. Left, 1, 2, 3. 1, 2, 3, 4, 5. And then once you draw your parabola in, just put arrows at the end. So this is A, and do a better job of a parabola than me. Okay, so now we have the vertex. So now we're going to go left 5. Remember, it's opposite in there. And up 6. So 5, 6. And then the vertex is going to open down. And the step pattern, so we've got 1 times -4, 3 times -4, 5 times -4. That's a pretty big step pattern. I don't know how far we'll get. So over 1, down 4, 1, 2, 3, 4. Over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Over 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so these questions, please try the homework, please. So the more practice you get with what's the step pattern, whatever, there really isn't a huge amount of variety. Just getting used to what the different translations and things like that mean. Excuse me. Okay, if you have any questions, just email.